Hello everyone, welcome back to Prep Pro Papers. Now we'll be heading to part 3 of this video for solving chemistry 2024 JGEEBILS previous year question paper. Now for the first question, an organic compound contains carbon, hydrogen and sulfur. If it contains 4% sulfur by weight, the minimum molecular mass of the compound is. Okay, so for solving this, let's consider there are three terminology which we need to know. This is minimum, and we know that only the sulfur content in this compound is given, that is 4%. So let's consider for it to be minimum, it has just 1 unit of sulfur. The molecular weight of the sulfur is 32 grams to 30 grams AMU. So if there is and let the molecular mass of the compound be X. So now it will become, for the 4% of sulfur, that is 4 by 100 of X is equal to 32, because as 1 unit will weigh 32 grams. So from here the X value will become 32 into 100 divided by 4, which will give to 800. That is option number C. Now for the C part, arrange the following compounds in increasing order of COH bond length: methanol, phenol, para-ethoxyphenol. So now we know that resonance will make the electrons to be moving around in that resonation circuit, and thus the COH bond length will decrease. So phenol is here resonating, and when we talk about between the para-ethoxyphenol and methanol, let's consider what the para-ethoxyphenol and methanol. So for the methanol, we have CH3OH. The COH bond is influenced only by the electron donating inductive effect of the methyl group, which is relatively weak. When in the case of the phenol, the hydroxyl group is attached to the benzene ring, the lone pairs of electrons on the oxygen atom can participate in resonance with the aromatic ring, which will slightly shorten the COH bond. And for the para-ethoxy in this compound, the presence of an electron donating ethoxy group will in the para position related to the hydroxyl group further enhance the resonation effect, leading to the slightly extension of the COH bond length compared to the phenol one. So the best option for this will become option number A. If you didn't got, let me write it, because it is why between the phenol and para-ethoxy, because this is having an extra electron donating part. Now for the question number 3rd, it says which enzyme can be catalyzed like perchloric acid in Baeyer-Welger reaction. Now we know in the Baeyer-Welger's reaction, the ketones to ester using peroxy acids with coenzyme. So in the what had happened in this reaction is that if there is an oxygen present with respect to FADH2, this will get converted to ester group, will give an FAD. So here the coenzyme which is used for the flavin complex oxygen to insert into this atom, it will be flavin monooxygenase. Now for the 4th question, The pK of the amino group of a deuterium is 9.6. In a 0.1 molar solution of the deuterium at pH 9, what percentage of amino group of the deuterium is protonated? So we know what the pH formula is given as pKa plus log of A minus concentration upon HA. And from here, when we solve, log A minus HA will become pH minus pKa log A minus HA. pH given is 9.6 minus pKa given is 9. Sorry, I read wrong. The pH given is 9 and the pKa given is 9.6, which will come to minus 0.6. Again, now A minus HA concentrations will become anti-log of 0.6. So A upon HA will become is 20. We know that A minus will now become minus 20 HA, and HA plus A minus concentration is 0.1 molar. So when we substitute from this, the percentage of deuterium which will be promoted will become 0.1 minus 0.2 upon the 1 into 100, which will come to 80%. Option number A. Now the next question says, during the process of oxidative phosphorylation, which molecule acts as a terminal electron acceptor? So we know during the oxidative phosphorylation, the process that occurs in the mitochondria during cellular respiration, oxygen acts as a terminal electron acceptor. Oxygen then combines with the electrons and hydrogen ions at the end of the electron transport chain to form the water. So the answer is oxygen. In the factual question. Now let's come to the next question, which says, which is the better electrophile center? Now let's check upon everything. First, because of the electrophile center, what are they? To determine which compound has better electrophilic center, we need to consider the electron withdrawing effects of the substituents attached to the carbonyl group, that is the CO group. The strength of the electrophile center is increased by the electron withdrawing effects of the substituents. This effect stabilizes the partial positive charge on the carbonyl carbon, making it more susceptible to the nucleophilic attacks. So let's see, for the first option is the acetone. For the acetone, the substituents are both alkyl groups, which are weakly electron donating, so it's making it to be a less electrophilic center. Now for the acetyl chloride, the substituent is chlorine and an alkyl group, and the chlorine atom shows a strong electron withdrawing, so making it to be a very electrophilic in nature. Now for the acetaldehyde, the substituent here are the hydrogen atom, which does not have any significant electron withdrawing or even the donating group. And now for the next, we have the bromine, which is having an electron withdrawing, but it is comparatively to the chlorine has more electron withdrawing effect, so the answer will be acetyl chloride. Let's come to the seventh question. The two strands of a DNA double helix are linked by each other by, this is common sense, so we know that the bases are A is linked to the T and G is linked to the C, and these are done by the H bonds. So the answer is C option. Again, this is because of the functional group change is here. These are functional isomers. Coming to the ninth question. Uh, what does allosteric inhibition of an enzyme by ligand mean? So let's go with the option. The binding of ligand to the enzyme inhibits the binding of the cognate substance at the same amino. So no. When we see upon the in the case of allosteric inhibition, we draw like here is your enzyme binding and here somewhere see that there is an allosteric inhibitor. So if here an inhibitor binds, so it will affect this enzyme not to bind here. So for this, the first option is saying for the same binding site, which is false. Second option says the binding of a ligand to the enzyme inhibits the binding of the cognate substrate at the different binding site, which is true. Ligand binds with protein covalently. No, this is non-covalent interactions. All the binding sites are occupied by the ligand. No, there are the inhibitor also coming. So the option number B. Question number 10. In the case of a fluorescence resonance energy transfer, the which of the option is correct? So in fluorescence resonance energy transfer, which we call as the FRET, the energy donor is fluorophore that, when excited by the light at a specific wavelength, transfers its energy to an acceptor fluorophore. So the key points here to remember are the energy donor typically has a the donor has a typically higher energy and therefore it has a shorter wavelength. The energy acceptor absorbs this energy and usually emits the wavelength to be more longer. So the correct option from this will be smaller excitation and larger excitation for the energy acceptor and the energy donor. Number A. Let's go to the next question. Protein X contains 192 amino acid and monoubiquitinated at two residues. What could be the probable molecular weight of the protein? Molecular weight of the ubiquitin is 8 kilodaltons. So this question can only be solved if you know the molecular weight of the amino acid, which is approximately 110 not kilodaltons, sorry, daltons. Let's convert this. If there are 192 amino acids, each multiplied by their molecular weight of 110 daltons will give us 21120 daltons. Let's convert it to kilodaltons, which will become 21.12 kilodaltons. Now we have two residues which are ubiquitinated. So ubiquitinated residues weight will become 2 into 8 kilodaltons. That will come to 60. Let's add this. It will become 1, 2, 7, 3. So the option here is option number C. Next question is relatively very easy, just a formula of speed, distance, and time. A kinesin motor moves at 1.8 micrometer per second. If it is walking on a microtubule of 10 millimeter in length, how long will it take to cover the entire distance? Okay, so we know that time is equal to distance upon speed. Here the distance is 10 mm. So 10 mm when converted to micrometer will become 10 to 1000. That will 10,000 micrometer become for the time will become 10,000 kilometer upon 1.8, which will come to approximately to 5,555.55555 will go on like 6 seconds. Let's convert this into minutes. That is to divide it by 60. It will become approximately to 92.59 minutes. That is option number B. This to the next question. The molecular formula for amino acid glycine is C2H5O2N. What would be the molecular formula for linear peptide made by linking 10 glycine molecules by condensation synthesis? Okay, so it is by linking 10. So we know that every time a condensation reaction happens, there is a loss of a water molecule. So if there are 10 C2H5O2N and there will be a minus loss of 10 water molecules. I'm sorry for linking two molecules or during condensation, there will be a loss of 1. So for 10, there will be a loss of 9 water molecules. Solve this. This will become C20, H50, O20 and 10 minus H18, O9, which then when we will solve will become C20, H32, O11, 9, 10. So it will be option number C. Let's go to the next question. So the next question says, in an unidirectional reaction, the conservation molecules X to Y follow second order rate kinetics. If the concentration of X increases by 3 times, what will be the change in the rate of formation of Y? So in the second order reaction kinetics, the rate of the reaction is proportional to the square of the concentration of the reactant, where K is the rate constant and X is the concentration. So when if the new rate becomes, this R dash will become rate 3, as the concentration is into 3 times into square, that is 9kx square, that is 9 times of the original rate. So option number C. Coming to the next question. In some carbonated beverages are made by forcing carbon dioxide gas into the beverage solution. When a bottle of one kind of carbonated beverage is opened, the beverage has a pH values of 3. After the beverage bottle is left open for several hours, the hydronium ion concentration in the beverage solution decreases to 1 by 100th of the original concentration. What is the new pH of the beverage solution? Easy. We know pH is equal to minus log of the hydronium ion concentration. So initially the pH given to us is 3. So the initial hydronium ion concentration from this will become 10 की power minus 3 molar. For the final concentration of hydronium ion, we know that it has become 100th time of the original, that is 10 to the power minus 5 molar. So the new pH will now become minus log of the hydronium ion concentration, that is 5. So now we have solved. In the previous videos we have checked upon for the general section, physics section and the chemistry section. Upcoming will be the biology section in the part 4. Stay tuned to the channel, subscribe it for the more content. Thank you.